Hello students, let us start off with the topic of mathematical logic. It is also called as sometimes mathematical reasoning. So this forms the part of what is called as foundation of mathematics. That is, it's one of the core areas on which the mathematical structure is built. So what it means is it's something like rules of a game. So if you think of mathematics as a game, then this logic lays down the rules according to which the game is to be played. Or just to give another analogy, logic is somewhat analogous to grammar of a language, right? Like grammar tells us how to use a language, okay? What is proper, what is not proper. So in that way, mathematical logic ensures, or it tells us how to use the mathematics, or how to deal with different proofs and theorems and conditions in mathematics. Okay, so let us go on and let us learn the starting point, that is the important concept in mathematics, that is called as a statement in mathematics. So what do we call a statement in mathematics? So it's a declarative sentence which is either true or false but not the both simultaneously, is called as a statement in mathematics. So here the true or false nature is called as the truth value of that particular sentence. So each statement is going to have a truth value. So let's take an example here. Like when we say that 7 is a prime number, okay, it is declaring something, it is telling us some information. Now it may be true or it may not be true, but of course not both simultaneously. And we know that 7 is a prime number. So clearly it is a true statement. If you look at the second statement, that is Rome is in India. Now this is also declaring something, alright, but we know that it is not true, so it is false, but nonetheless it is still a statement because it is declaring something. Alright. Now we saw what is a statement. We have to also see what is not a statement. Okay, so let us go ahead and see different types of sentences which are not considered as statements in mathematics. So which are not statements in mathematics? First one is imperative, that is an order. For example, come in. So here when we give an order, it is an imperative which is not a statement because we cannot assign a true or false value to an order. It is simply meaningless. Secondly, interrogative, that is a question. So how are you? Or that kind of questions are not, once again, statements. Third is exclamatory, that is when we show some emotion. It's like what a match it was. Alright, so these are not the statements because there is no meaning in discussing their truth value. Moving on, there are further additional types. Fourth one is prayer or a wish, like when we say hope you get well soon. So this is where we are just wishing something, so it's not a statement. Then next one is an open sentence, something like it is blue in color. Now here, although it feels like it is telling something or declaring something, the problem is we cannot say whether it is true or false unless we know what does this it stand for. Right? So if that it stands for sky, then we'll say that yes, sky is blue in color, so that's true, but not otherwise. So it is ambiguous case. The next one is subjective opinion. For example, when we say that Paris is the best city in the world. Now different people may have different opinions about Paris, isn't it? Like someone may not think that Paris is the best city in the world, or someone may think that it is the best city. So whenever we cannot clearly assign true or false value to a particular statement, that is not considered as a statement in mathematics. And lastly, we have an interesting case that is called as a paradoxical statement or a paradox. And here we have a famous liar's paradox, that there is a statement that is I am lying, that is I am not speaking true. Now here also it seems like it is declaring something, so how can it not be a statement? So let us quickly evaluate both the possibilities. Suppose we assume that this statement is true, that is I am lying is true. That means what I am saying is true. So if I am lying is true, that means I am actually not lying, isn't it? So the opposite must be the true, which directly contradicts to what I am saying. On the other hand, if we think of this statement to be false, that is, I am lying is false, that means I am not lying, and which means I am speaking true. So that again contradicts what was told originally. So therefore here we'll end up in a difficult situation and we are not able to assign a single truth value to this sentence. Therefore it is not a mathematical statement, right? Let us go ahead and just remember two important points here. That is, a simple statement is denoted typically by the lowercase letters such as P, Q, R and so on. And secondly, all the identities in mathematics are true statements, because like we know that's the meaning of the word identity. That is, it's an equation which is true for all the values of the variables involved in that particular equation, right? So therefore the identities are always the true statements, of course within their own context. Let's go ahead and solve a simple question based on this. Identify which of the following are statements in mathematics and state their truth value if applicable. So if this sentence is a statement, then we have to also state whether it is true or false. First one is 5 is a rational number. Now we know that this is a statement because it is telling something, and it is true because 5 is really a rational number. Second is please give me a water. Now here we know that it is an order or an imperative, so therefore it is clearly not a statement, so therefore no question of stating the truth value. Third one says x plus 2 equal to 6. Now here you may wonder that yeah, it is true because 4 plus 2 is 6, that's what we do mentally. But unless we know what value x has, we cannot say whether that satisfies the given statement or not. Right? Here the intention is not to find the value of x which satisfies the equation, but just to state whether this statement is really a statement in mathematics or not. So therefore, being an open sentence, it is not a statement. Next is sin 2 theta is equal to 2 sin theta cos theta, where theta is a real number. Now from trigonometry we know that this is an identity, so that means it is always true for any real value of theta. So clearly it is a statement and it is a true statement. Then next is every parallelogram is a rhombus. Since it's telling some fact, it is a statement, but we know that every parallelogram need not be a rhombus. It's only that parallelogram whose all the sides are equal is a rhombus. So therefore the truth value is false. And lastly, why are you angry? As we can see, it's a question or an interrogative statement, so therefore it is not a statement in mathematics.